Alright, let's take a look at some examples together. We'll do a few. The book realizes that this is your first exposure to these types of concepts, so it asks about all these theorems and Descartes' rule of signs and all of that. There's also something I haven't brought up yet that I thought I'd just bring up during the examples. And so if I go through some of the initial examples, we'll do some that we kind of did in the last video. F of x is equal to 4x cubed minus 10x squared plus 6x minus 2. And the question is to use the remainder theorem to find the remainder when f of x is divided by x minus 2. Okay. And then we're going to use the factor theorem to determine whether x minus 2 is a factor. Okay, so what do? Well, we could do what they modeled in the book. We can either do synthetic division or plug in 2. Let's just plug in 2. We could do that. That's 4 times 2 cubed minus 10 times 2 squared plus 6 times 2 minus 2. I'm hoping you're comfortable with us plugging in 2. It is x minus 2, but if you remember that theorem, you would evaluate it at 2. And that makes sense. That should make sense from the zeros that we did earlier in the sections. When we knew something was a 0, if they said 3 was a 0, then we knew x minus 3 was a factor. We're just basically using that. So what is this? This is 4 times 8 minus 10 times 4 plus 6 times 2 minus 2. 8 times 4 is 32 minus 40 plus 12 minus 2. And if we look at 32 minus 40 plus 12 minus 2, we get a 2. So we get a nice 2 out of that. Well, that's the remainder. So the remainder is 2. Now, because the remainder is 2, x minus 2 is not a factor of f of x. And you know that because if you tried to divide it by it, the remainder would be 2. It didn't go in evenly. It's only a factor if it's 0. So those are the questions you're going to answer to start out with. There are a few questions in this section, but some of them are easily answered like that, quickly answered. Here they have f of x is equal to negative 7x to the 7th plus x cubed minus x squared plus 8. And this question asks, A, what are the max number of zeros for f of x? And the max number of zeros is the degree of the polynomial, so it's 7. So that'll be really quick. They just want to enforce that. It's going to have no more than 7. Descartes' rule of signs. So we'll say apply Descartes' rule of signs to find the positive real zeros. Use the Descartes' rule of signs. I shouldn't word it like that. I'm going to take back my wording there. So use Descartes' rule of signs to find the number of positive real zeros and negative real zeros. Okay, let's do that. So, Descartes' rule of signs. Let's look at the number of sign changes in f of x. So I'll write f of x here. Negative 7x to the 7th plus x cubed minus x squared plus 8. Do you see how many sign changes there are? There's 1, 2, 3 sign changes. So the number of positive real zeros are 3 or 1. I think as you enter it into the into the computer, you have to do a 3 comma 1, right? That's how it's going to have you put it in there. And so you do need both numbers in there. I did check to see if it would just take the 3, but it wants all the potential ones because there might not be 3. There might only be 1, right? That Descartes' not telling us exactly, but it is telling us there's one positive one. So go crazy, find that positive one. Typically they're nice. How about the negative? Okay, well, what are we going to have to do for the negative? Well, we're going to have to look at f of negative x. Well, let's look at that. That's negative 7 times negative x to the 7th plus negative x to the 3rd. Maybe I shouldn't have scrunched it in there. I'll go below. So f of negative x, negative 7 times negative x to the 7th plus negative x to the 3rd minus negative x squared plus 8. And so what's that? Negative x to the 7th is going to be negative times negative 7 is positive 7x to the 7th minus x cubed minus x squared plus 8. And look how many sign changes we have here. 1, 2. And again, it's like our next one. We have, or last one, 2 or 0. And so that's what you're doing as you go into the homework. They'll have you play around with these things. In our third example here, as we go to our third one, I got to explain something. They're going to give you a function. F of x is equal to negative 9x to the 7th minus x to the 6th plus x plus 3. And they want you to list out all possible rational zeros. And so there's it's in the book, towards the end of the section, they talk about the possible rational zeros. So I thought it would be easier to explain. I definitely couldn't type it out because I don't have a math type of thing on my iPad. And so it's easy to read in the book, I think. But the way that you list out all possible rational zeros, and in essence what you're doing is you're looking for the nice potential zeros, because you don't want to try everything. You want to try only things that have a potential to work out. And so the way that it works is it's plus or minus the factors of the last term over the factors of the first. Okay. And maybe I shouldn't say the last term. Let me say the constant term. Okay, so what do I mean? So for this problem, it's plus or minus factors of 3 over factors of 9. Forget about whether they're positive or negative because you're taking care of that here. So if there's going to be a nice factor, it's not going to be anything. It's going to be related to those bookend types of things. And you know that through thinking about FOIL and stuff. And there's a decent proof in the book. So this is the way I do it. I remember that it's plus or minus. Now, what are the factors of 3? They're 1 and 3. And the factors of 9 are 1, 3, and 9. And you just start stacking. So I do it very systematically, always remembering plus or minus. So plus or minus 1 over 1. I'm going to circle the 1. I'm going to start with the 1. I'm going to put 1 on top of everything, comma, plus or minus 1/3, comma, plus or minus 1/9. You okay with that? So 1 over 1, we know that better. That's just 1. That's how we'll write that. I just didn't want to lose you in there. So that exhausts everything with the 1 on top. So now I'm going to come in here and maybe a red highlighter, I'm going to X out that 1. I've exhausted that. Now let me put the 3 on top. And I'm just pretty systematic as I go through here. Plus or minus, 3 over 1, which is 3. Plus or minus 3 over 3, but 3 over 3 is 1. Right? So I can write 3 over 3, but I'll realize very quickly I've already got it. So that guy's related back here. So I don't need to write that. So I don't need that one. And then 3 over 9, I think I already have that one too. 1/3. Already there. And so you get some duplicates in that process, but that's awesome because look what it means. It means these are the only factors that can be possible. So what's the computer need you to do? It needs you to list them out like this: -1, comma 1, comma -1/3, comma 1/3. Actually, I don't think it has you listed out. I think they have you match it. Yeah, I'm pretty positive that every problem I saw had you match it to the right combination. And so you're not going to duplicate things, but what's awesome is you would just try, if you're going to try factors, you just try any one of these guys. It wouldn't be all over the map. And so the rational zeros function really helps. So they have these upfront problems where you're practicing small principles, and then the remaining problems are all these big problems that basically say find all the factors. So as our fourth example, in this 4.6 section, we're going, just making sure, yeah, our fourth example, find all real zeros of f of x equals 2x cubed minus 4x squared minus 22x plus 44. And so they're just going to pick something big, right? And we could try to factor it. I mean, that's not necessarily a terrible idea to just try to go and factor it. So I want you to be creative. You do not have to follow process or a specific process, but you do need to be prepared for using a principle in those times that the factoring just doesn't work. So I'm going to model the current principle. The current principle would be, okay, let's decide on what all of our zeros could be. Well, it's going to be factors of 44. Well, let's see what Descartes' rule of signs says. So Descartes' rule of signs says that there's 1, 2, there's either 2 or 0 positive real roots. Now, they don't even have to be rational, right? And so we're just banking on them being rational. As we try this, if we can't find any, then we just got to keep going. So, and if I looked at the negative, I'd find out that. But this is enough for me to know that there's a potential that we have a positive real root, or even a negative one. But let's see what those potentials are. They call when I did the factors, they call it P over Q. I think it's P that they put on top. But this is the factors of 44 over the factors of 2. And so that's 1, 2, 4, 11, 22, and 44. All over either 1 or 2. So it could be plus or minus 1. As you put them all over 1, you get those numbers up top. If you put them all over 2, you get 1/2, the 1 again, the 2 again, 11 halves, the 11 again, and the 22 again. And so, you just think about those stacks. So here's where it gets a little dicey. And you have to just guess, right? And say, okay, what's going to make this happen? And so my suggestion is the first thing to say is you may choose wrong, and that's fine, right? There's no wrong choice, but you may not get that 0 right away. Synthetic division you'll want to do in pencil because you're going to do a lot of erasing here. So I would look at this and I would think, okay, it can't get too big because it's all got to be offset by a 44 in the end. So I can't get my numbers too big. So I can't be plugging in like 44 in there because 44 cubes is going to be huge. So I'm ruling out in my mind things like 44 and 22 because they're going to get really big when I cube them and not be offset by these other numbers that are down here. 11 seems pretty high too, so I'd probably start mid-range, maybe not at 1, but at 2. So let me start at 1. Let's start with 1. I would try to see if 1's a factor. Now, if I'm going to see if 1's a factor, I'm going to put it in right here. I'm just going to focus on the positives. Recognize that these are all plus or minuses. But I'm going to just start with the positive. And so as I start with the positive, I'm going to bring down the 2. 1 times 2 is 2. And then I add those and I get -2. and then I get negative 2 again, and I'm realizing really quick that I'm not going to get that 44. And so what do? I'm doing things in pencil. So I'm erasing, and I know 1's out of the picture. Now I haven't ruled out negative 1, but I know positive 1's out of the picture. Let me try positive 2. And bring down the 2. 2 times 2 is 4. 4 minus 4 is 0. 2 times 0 is 0. 0 and negative 22 added together is negative 22. 2 times negative 22, oh, look at that. Negative 44, and I get a remainder of 0. So from the factor theorem, because I have a remainder of 0, I now know that f of x, this big 2x cubed guy, is definitely x minus 2 times something, and we have times right here. Times 2x squared minus 22. That's what this polynomial is. That's why it's so good to do it through synthetic division, because then you get something that you know about. Well, you know all about this 2x squared minus 22, so they want you to find the other roots. Well, one of the roots is 2. So I call them roots, sorry. Some books call them roots, other books call them zeros. Our book calls them zeros. So one of the zeros is 2, and the other one comes from this second polynomial. Well, we know how to do that. This is a beginning algebra problem where you're using the square root property, and you're coming up, don't forget your plus or minus, with root 11 and negative root 11. You'll have to write them out separately as you list those zeros out in the computer, but there are your zeros, and you're completely done. Now it is going to ask it to you in factored form, and I checked, and this is how they want it. Okay, not like what's up here. They want it in its pure factored form. Just like that, where you have those 3 zeros all there. Okay, that is what's going to help us to get the right answer out of this guy. And so, oh, and apologize, they'll need a 2 out here as well, right? Because we lost that 2. So theoretically, we'd factor out the 2 and be left with x squared minus 11. We do need that 2 in there so that we get the 2x squared coming out. So I'll model that again in another problem. But this is the challenge of this section, is to come up with these rational zeros. Let's look at one last one together. And again, I'm getting these, every problem that I've done here I found in the homework. Same thing, find all zeros. Find all real zeros of f of x is equal to 7x cubed plus 3x squared. Let me not get sandwiched in there. I'm going to come down here. F of x is equal to 7x cubed plus 3x squared minus 29x plus 11 equals 0. And so what do we get as our rational zeros that we could try? Well, we get plus or minus 1, plus or minus 11, plus or minus 1/7, plus or minus 11/7. We just get those limited ones. We could look right here, in Decartural Signs would tell us that there's either 2 or 0 positive real roots. Okay, only 2 or 0 positive real roots. Well, we could go hopeful for 1. Okay, we could look at the negative 1 too and find out how many negative roots there are. I don't know. I'm just going to focus on the positive roots right now. I would totally suggest synthetic division. Let's see what our thing looks like. 7, 3, negative 29, 11. Okay, and then we're going to put something up here. Now the negative 29 is going to balance some things out, but we need to be careful. So let's try something like 1 again. If I put a 7 in there, 1 times 7 is 7, 7 plus 3 is 10. 10 and negative 29 is negative 19, and that's not going to work for the 11. So it's not the 1. And so we can come in here and we can erase the fact that it could be positive 1. It could be negative 1. Let me try the negative portion of it, right? negative 1. So we get 7, negative 4, 4, and no, it's not going to work. There's no way that's going to get me an 11 that's going to then be a negative 11. So the negative 1 didn't work. And so you can start peeling away these factors. We can think, well, it's got to be a nice number, right? Let me try 11. 7, 77, 80, really big, and way too big to compensate for the 11 that's in the end there. So we're going to put a negative on there and try that one. And as we do that, let's see what happens. So you can check these really quick. Notice that as I'm checking these, you can think this is a big time. We're checking them in under a minute. 7, negative 77, negative 74, really big. Minus 29 is not going to somehow get me a small number that when times negative 11. So it's not any of the 11s. So those are gone. So guess what? Our hope are in the fractions. Let's try 11 sevenths. Okay, 11 sevenths times 7 is 11 plus 3 is 14. That's good. 14 times 11 sevenths is 22. Okay, and 22 minus 29 is negative 7, which is negative 11, which is 0. Awesome. So what do we know? We know f of x has a 0 of positive 11 sevenths. We know it factors as x minus, I was going to put pi. I don't know why I was going to put pi. 11 sevenths. And then times, and we know it's 7x squared plus 14x minus 7. Now what would I do next? Remember, they want the factorization in the end. This is x minus 11, almost did it again, 11 sevenths. I'm going to pull the 7 out and look at this polynomial. Are there factors of 1 that subtract to be 2? Nope. So I got to go find the zeros of this one. So we know one of the zeros is 11 sevenths. Another 0 is, well, let's go find out. When does x squared plus 2x minus 1 equal 0? Well, this is a nice Algebra 1 problem, best solved in terms of efficiency with completing the square. You can do the quadratic formula. It probably will take you longer. X plus 1 squared is equal to 2. X plus 1 is equal to plus or minus root 2. X is equal to 1 plus or minus root 2. And so the two other roots are 1 plus root 2. There's your second positive. We knew if we had 1, we'd have a second. And our negative is 1 minus root 2. So there must have been an odd number of negatives that would allow us to have 1 in there. Odd number of sign changes in that negative 1. Perfect. Now they are asking it for a completely factored form. So what's that look like? That looks like 7 times x minus 11 sevenths times x minus 1 minus root 2 times x minus 1 plus root 2. And we have that factorization. They need you to type it out just like that. I tried it with this version of it, these top ones, and it didn't accept it. It needed it in its fully factored form where you could see the factors in it. So that's what's happening in this section. Totally doable. It's going to pull on your old skills, right? Quadratics and stuff, but you're trying to rip out a root to get it to be something that you recognize. All right. Good luck in 4.6. 4.7 is a little nicer. All right. Take care. We'll see you soon.